Hey, if you're a physics student looking for help, I'll be showing how to solve many different types of physics problems, starting with this past AP Physics test question. This question is about a cyclist who rides down and then back up a ramp, jumps over 6 cars, then lands on another ramp. This video will cover part A of this question, where we're asked to derive an expression for the distance, x naught, that the cyclist will travel while in the air. The first thing we should always do when starting a problem is write down our knowns and unknowns. In this problem, we're not given any values, just told to derive an expression for x naught using the given terms. So h naught, theta naught, and m naught will be our knowns, and x naught will be our only unknown. For this type of problem, where there is a change in height and velocity, it should stand out that the energy equations can be used. Looking in our equation sheet, we can find the formulas for potential energy and kinetic energy. From the conservation of energy, we know that the total energy at one point will be equal to the total energy at a second point, making the cyclist's start point the first point, and where the cyclist leaves the ramp the second point, we have E1 equals E2, and then U1 plus K1 equals U2 plus K2. Initial velocity is 0, so K1 will be 0, and we can make this height the origin, so U2 will be 0. This leaves us with m naught g h naught equals 1/2 m naught v2 squared. Solving for v2, we get square root of 2g h naught. Now, if we make where the cyclist lands point 3, we can again apply the conservation of energy law to see that v2 will equal v3. I'm going to clean this up a bit to make some more space. We're given theta, so we can break down both of these velocities to their x and y components. Vx will go to the right for both and will be equal in magnitude since there is no force in the x direction while the cyclist is in the air. Vy at point 3 will have the same magnitude as point 2, but will now be going down. Cosine theta naught will equal Vx over V. So Vx equals V cosine theta naught, or from what we found before, cosine theta naught times square root of 2g h naught. Similarly, sine theta naught will equal Vy over V. So Vy equals V sine theta naught, or sine theta naught times square root of 2g h naught. Again, I'm going to clean this up. Now this x direction distance can be found by multiplying the velocity in the x direction by time. We have an expression for Vx already, and we just need an expression for time. Looking through our equations, we can see the kinematic equation V final equals V initial plus A t, or V3 equals V2 plus AT. We can simplify this equation using the velocity components we just found, but we can't use Vx because A will be 0 and then we can't find time. Instead, we'll use Vy, where A will be acceleration due to gravity. Since Vy is pointing down at 3, we can write negative Vy equals Vy, and since gravity will also be pointing down, negative gt. Solving for t, we get t equals 2Vy over g. Substituting our value for Vy, and this becomes 2 sine theta naught square root of 2g h naught all over g. Finally, we can substitute Vx and t into our x naught equation, leading to cosine theta naught square root of 2g h naught times 2 sine theta naught square root of 2g h naught all over g. This can be simplified to 4 sine theta naught cosine theta naught h naught. This answer can be simplified again using trig identities to get 2 h naught sine of 2 theta naught.